So we're going to do shortcuts. Okay. We're going to do some special cases. Your book goes through case 0, 1, 2. So case 0, constant dividends. So for I equals 1 to infinity, di equals whatever I expect it to be next year. So if dividends are going to be $10 per share next year, this case assumes that they're going to stay at $10 until the end of time. Then the sum above simplifies. Writing it in summation form. This is simply a fancy notation for each value of t, calculate that expression and add them up instead of writing it like this. You know, for t equals 1, t equals 2, t equals 3. And if all of them are equal to d1, d1 comes out of the summation sign. Now, thankfully, that infinite summation is convergent. And this is actually equal to d1 over r. For example, Coke is expected to pay, and I don't have to guess, $1.94. And assume dividends will remain constant. I don't know why this thing, okay. At that level, and suppose R equals, for ease of computation, 10%, then we should have value 194 divided by 10%. I chose 10% because dividing by 10% is the same thing as multiplying by 10. Well, what's the price of Coke? $60. So it's probably not the right model, but that's kind of how we would do it. The second case, in fact, I'm going to call this case 1. Dividends are expected to grow at a constant rate. G, then I'm just going to go ahead and write the number. P0 is going to be $D1 divided by R minus G. Okay. Again, using same example, suppose G is 6%, right? And R is 8%. Then P0 is going to be 194 divided by the way, for this model to work, case one, you want R to be greater than G. Otherwise, the equation that defines that infinite sum is not convergent. Well, I chose these because you're dividing by 2%, which is the same thing as multiplying by 50. And 194 times 50 is going to be $97, if I'm not mistaken. All right. Again, that's too much too, but you see where we're going with that. The third case is you may have somewhat of a good idea about what the dividends are going to be over a few years, 3 years, 5 years. And after that, you're going to assume they will grow at a constant rate. Okay. This is the so-called two-stage growth rate, growth model. For, let's call it T periods. And after that, they are assumed to grow at a constant rate of growth rate of G. In order to solve this problem, I'm going to divide this firm into two. There's a cash flow from this firm, right? You can actually technically issue securities that has different claims of cash flow from a firm. You can say, share class A, you guys are entitled to the dividends for the next 5 years. After that, you get nothing. Okay. Class B, you guys will get nothing as dividends for the next 5 years, but after that, you will get all the dividends. This is legally possible, by the way. You can do that. Not that anybody does, but you could. So I'm going to call this early company or early firm entitled to dividends for the first 3 years, and the late firm entitled to 0 dividends for 3 years, then all the dividends after. If I can calculate the value for the early firm and the late firm, all I have to do is add them up to get the value for the firm. Because if I own one share of each, I own the entire right to the cash flow from firm's dividends, right? So value of early plus value of late is equal value of firm. We always do that in mathematics. We have a complicated problem, we divide and conquer because we know how to do certain things. For example, the early firm for T years, I'm going to get D1, 1 plus R, D2, 1 plus R squared, dt. But I know all those numbers, so all I have to do is calculate them separately and add them up. In fact, we're going to build a template in Excel to take care of all of those, but that's how we do it theoretically. That part is easy. Now, value of the late firm. You get nothing for 0 years, but after that, you know, you can think of this first and foremost, the dividend for T plus 1 is going to be dividend for T